I mean, you should just play it by ear.
The chances are good that I will screw it up regardless. It doesn't really matter.
Okay.
What we're going to do.
I'm okay with that.
All right. Here we go. Everybody, welcome to the PC Perspective Podcast. This is episode 481, being recorded on December 27th, 2017. I'm Ryan Schrow.
I'm Josh Walrath.
And playing the role of Alvin Malventano tonight is Ken Addison.
Alan Maltavino.
I'm the understudy.
Yeah. Only three of us on this one. Well, plus Alex behind the board back there, and Jim hiding way in the back. You can't really see him, but
he doesn't acknowledge us anymore.
Jeremy's like on Canadian vacation. Alan is on a farm someplace.
Canadian Vacation was the worst of the National Lampoon's movie.
Yeah,
it just wasn't that interesting while I was fishing.
It's the end of the year. It's our second to last podcast before CES. We do have another podcast that we'll record before we leave for that show. So we don't need to get into CES predictions or that kind of BS, which inevitably is incorrect and boring, and we don't really say anything interesting anyway. So whatever. We're moving on. Welcome to the show. It's Josh. It's nice to have you back. How was your?
It's nice to be back
to Texas.
It was long, and
was it strong?
It was long. I had two teenage boys. The going down there wasn't too bad because they slept most of the way.
Well,
and so did my wife, and so it was a lot of me time. And coming back was not nearly as much fun.
They were
okay. How much farther is it? Are we in Denver yet?
Yeah.
What? We're not even in Amarillo. What do you mean Amarillo's on the halfway point?
The way back is always the worst.
Yeah, regardless of the trip, the way home is like when we drive to Texas from here. How much driving is it for you to get to where you were going?
16 hours.
Okay, so it's about 15 hours from us when we drive to QuakeCon, for example. It always seems to take longer the way back, but teleportation, it's the hot new thing, I think.
Just take the Hyperloop.
Exactly. We record the show on Wednesday nights, everybody. 10 p.m. Eastern, 7 p.m. Pacific at PCPer.com/live. You're welcome to join us there. We have a chat room. You can hang out with all the other people watching. We watch the chat, respond to your questions and funny comments every once in a while, some more than others. If you need a gentle reminder about when we're going to do a live stream, you can go to PCPer.com/subscribe. You get this page here. It basically asks for your name, your email address, and we'll send you a note right before we do our live stream. So there you go, PCPer.com/subscribe for that. And of course, we still have our ongoing Patreon campaign at patreon.com/PCPer. This is your capability, your place, if you decide you want to directly contribute to PC Perspective and the reviews and the news and the videos and the podcasts that we do. It is a recurring thing. It could be anywhere from, it could be $1 a month. It could be $3, $5, $10, $50, $100, anything in between. And it goes directly to us and to the guys. We greatly appreciate this. And it enables us to do a bunch of cool stuff. And as always is the case when we record the show, if you become a new patron or increase your patronage during the show, we will give you a shout out on the live stream. So we thank you very much in advance for that. As he goes to look, here is one from Sean. Sean Skoczylas. Yeah. Kozillas. I bet there's several silent letters.
There's a lot
of
silent letters in
Thanks,
that.
Sean S. For the pledge of $1. We greatly appreciate that. So thank you guys. What that enables us to do is things like the mailbag that we now record every week, which is one of us sitting there answering questions for you guys. It's been me, it's been Josh, it's been Alan. This week,
you can see me looking around the other monitor to see the TV behind it so I can look at the menu options.
Right. Yeah, there's Ken. He's waving at us. There he is. See? There he is. I do like the one comment we had that Jim pointed out to us this week about the Ken was doing some graphics card benchmarking behind us, and there's a scene in our benchmark suite where people get burned at the stake in The Witcher 3.
But they're only witches. I mean, they're not people.
Well, probably they're witches, right? Let's see if I can find it here. And they said, like, oh, the mailbag took a much darker turn all of a sudden when behind Ryan's right ear there is people being burned at the stake.
Well,
I'm like,
you know, sometimes it has to happen.
can't make an omelet without breaking
GPU
a few
science.
eggs, right?
Yeah,
Isn't that how it goes? Yeah, there they are. There they are burning at the stake.
I'm not even paying attention. It's just boring to me.
Yeah, you've burned so many people at the stake at this point.
You are truly cruel and unusual.
Yeah.
That's what they said in high school.
On the unusual.
Oh, well. So that's the mailbag. You can find that on our YouTube channel, PCPer. Nope, youtube.com/PCPer. Although we do post them on PCPer.com as well. Let's jump into stuff reviews. We're full of content from Josh this week. He basically nonstop
wrote the entire
on his
thing.
Trip. His entire
I
trip.
overtook the site with my writing skills on the road. I dictated to my children, and they ignored everything I said, and they didn't upload it. And so there we have it. Just pretend that they uploaded it all.
Fair enough. Fair enough. I assume they'll get around to it in the next couple of days or so.
Sure.
In the meantime,
let me ask you this before we go in.
All right. Yes, Josh.
Was that Kylo Ren's topless body, or was that CGI'd in?
That was him.
That was me.
Dude, that guy looks so weird.
Why? What?
I mean, he was the love interest of Lena Dunham in Girls.
Yeah.
So
that show.
I mean, did he have these scars on his body or something, right?
Absolutely.
From the lightsaber? Did he have scars from like a lightsaber attack? Was that what it was?
From his face.
He had scars on his face, but didn't he have scars on his body too? I assume, Josh, you somehow paused it, freeze framed, and studied it later. I don't know.
He just took a mental photo.
Not the case? All right. Let's talk about the Titan V, the box of which sits in front of us again. This time, part 3, where Ken dove into the world of deep learning.
I took a shallow dive into the world of deep learning.
Oh, God. Ken's first attempt at learning comes as we basically... So the Titan V was a card. It was initially presented like that's its goal is for deep learning, machine learning, AI stuff, right? But we knew for us that was going to be our steepest roadblock, if you will. To
we've never exactly done any of that. I can run benchmarks blindfolded, gaming benchmarks and synthetic benchmarks.
So that's what we did. We did the games first. We did compute second, which is stuff that's a little bit more complex, but still a lot of off-the-shelf Luxmark testing.
Still using Windows.
Yeah, still using Windows. This time we have to dive into Linux. Oh, God, can you imagine? And use a bunch of libraries and things that we're just not familiar with. So it was a much steeper learning curve for us to get around to understand this stuff. But you did it. You did some benchmarking with this stuff. And what's important about the Titan V is that it uses Volta architecture, as the V would indicate, which means it has these tensor cores in it,
which aren't only good for TensorFlow,
right?
As you might think, not knowing a lot about this stuff. There's a framework called TensorFlow, and they're called tensor cores.
Right.
So you go, okay, well, those are probably built to accelerate a specific workload. No. A tensor is a mathematical object.
Okay. It is a
multi-dimensional array.
Yeah, as the slide here tells me in some capacity. So basically, what we did was we have a different platform for this. We're using a Threadripper system. This is something that was just convenient to us, something we could load down with a lot of memory.
Yeah.
These machine learning benchmarks require a lot of system memory. NVIDIA's testing used 128 gigs of memory. We only really had the ability to put 64 in any one system.
It turns out the DDR4 shortage affects us too.
Yeah. And fast storage is also important for machine learning benchmarking, right? So we wanted to make sure we were using a little bit different test bed than we would for our gaming tests, where they're much less sensitive to that type of stuff. So what was the setup process like?
So a couple weeks ago at what conference was that NVIDIA did the keynote at?
Oh, I don't know.
Supercomputing. It was at Supercomputing.
Oh, I thought it was like some weird NIT something.
No, that's where they announced the Titan V.
Yeah.
But at Supercomputing, they announced NVIDIA GPU Cloud.
Okay.
Which we didn't really pay a lot of attention to at the time because, they were presenting to a very specific group of researchers and scientists, and wasn't exactly something that we needed to learn about immediately. But it's actually pretty cool. So what NVIDIA GPU Cloud is essentially NVIDIA's attempt to create turnkey development solutions for applications like TensorFlow, like Caffe, for scientific applications, for all of this different stuff. So it's based upon Docker, and what they do is they have each month they release a Docker container for each application. So we're using the NVIDIA GPU Cloud 17.12 Docker container.
When you say each application, how many applications are there?
I don't know the full list. There's maybe like 15 to 20 at this point.
Okay,
maybe a
so
little
more
less
than
than
I
that.
thought. Okay.
Yeah,
all right.
It's a lot of deep learning
So that's
stuff.
responsibility on their part to upkeep
Yeah.
this stuff as well.
So essentially what you get is a containerized environment that you can run on top of. They usually recommend Ubuntu 16.04 with the latest kernel on it. And you install the latest NVIDIA GPU drivers on your local machine, and then you run this Docker instance, which has the CUDA environment set up, has, in this case, TensorFlow set up, automatically optimized for the newest features of the Titan V, like the Tensor Cores, which hasn't been mainstreamed back into the TensorFlow project yet.
Right.
So you have NVIDIA optimize and tweak development settings for each individual application so that you can just start to import your code and run it. You don't have to worry about compiling. You don't have to worry about optimizing certain environment variables. It's strictly meant so you can load this container and start running your TensorFlow code, or start running your Caffe 2 code, or start running whatever.
So we use those systems to test the Titan V and the Titan XP. What did you have to do for the AMD card?
For the AMD side, they don't really have anything like that, but they do have their ROC-M initiative, which is their Radeon Open Compute. I don't know what the M stands for, actually.
I don't know either.
Rock'em sock'em.
Exactly. So they have a lot of decent documentation about getting stuff up and running. In this case, we're using the HIP TensorFlow port.
Okay.
Because TensorFlow is an application written in CUDA. There's no OpenCL port, at least official. A couple of people have tried, but they're not very far along / abandoned projects.
Okay.
So NVIDIA or AMD used their HIP platform to translate TensorFlow, which is a CUDA application, to run on OpenCL on AMD GPUs.
Okay.
And in that, there's definitely a performance hit lost in that translation.
Oh, sure, yeah.
As you can see in this chart here.
So, okay, when we look at these benchmarks, look at these results, you have TensorFlow and you have ResNet 50, ResNet 152. What are these tests actually attempting to do? So
these tests are they're benchmarks, so they're not training a full neural net, but they're using data from the ImageNet data set, the ImageNet Large Scale Visual Recognition Challenge 2012, which is sort of one of the very common data sets that people use for developing neural networks at this point and benchmarking them. So essentially, it's just a large set of seemingly random images and descriptions of what those images contain. So it'll be like, this contains a dog, this contains a fish. It gets a little more specific than that. This contains a Josh. But you can go on the website and pull the specific list of all of the stuff they classify. But it's a image set meant to train a model so that you can identify, quote unquote, anything in a photo. Okay. So that's kind of what we're going for here. And the metric we get is images per second. So this is images a second that are trained into the neural net. Okay. Higher is better. Yes, higher is better. Okay. So ResNet 50, we're showing Titan V. There's also two sets of results, FP32 and FP16. FP32 is using the standard CUDA cores, if you will, and the standard stream processors of these devices, which indicates, like, you can kind of see, like, Titan XP, the orange line to the blue line of the Titan V. There's an increase there, but not an enormous jump. It's about what we saw in anything else, single precision. So if we looked at OpenCL rendering, gaming, all of that stuff, we saw about that 15% performance. Now, the FP16 results are the same. It's the same data set. It's just a different compute model with which to accomplish the task. Yeah. And these are actually using the Tensor Cores in that computation, correct? Yeah. So the way the environment's set up in the NVIDIA GPU Cloud image for TensorFlow, the latest couple images, they've sort of modified the code to allow FP16 training, which wasn't in the initial code. And that FP16 training code path uses the Tensor Cores. Okay. On the GPU. So then you get a jump from, again, even though it's FP32, FP16, it's the same data set, it's the same workload. Instead of getting 295, you get 531 images per second.
right? Or in batches of 64, which is how many images are sent into the algorithm one time, right? It goes from 268 to 469.
Yeah, so that's the other important variable here is that researchers doing deep learning will train with as large of batch size as they possibly can, because if you're feeding more images into the training model at the same time, then it's faster. It's a parallel process, right?
Right.
So batch size is limited by hardware. In our case, it was very limited by the amount of RAM we had in the machine, so we only had 64 gigs. So we could only hit certain batch sizes. And if you look at the results, we could only hit certain batch sizes we could hit larger batch sizes on FP16 than we could FP32.
Got it.
Because if you think about it, an FP16 integer has takes up less space than FP32. That's kind of part of the point, right?
Got it. So we tested. So is there anything significant in like ResNet 50, ResNet 152, GoogleNet, other than these are different data sets or different?
Not particularly. We just were training against different models to make sure that we saw similar performance gains among all of them.
It's pretty obvious looking at these results, like where the benefit is. The FP16 performance is there. The Vega Frontier Edition that we use, the liquid-cooled variant, is not competitive in this space at all. And I'd be curious how much of this is non-optimized software. It's clearly not just a huge hardware deficit. And I'd be very interested to talk with, and we've asked AMD and they just haven't gotten back to us yet with like, why are your results like this? We follow your steps. We're working on things the way we're supposed to be working on it. You're out there talking about your capabilities in the machine learning space. This is not indicative of somebody who is taking, like, you're an order of magnitude slower than a Titan XP.
Yeah. And if you think about it, the Vega is very good at FP16. Yeah. So you should be able to see large gains there as well.
Yeah,
using high precision.
You're right.
Compute.
And you also ran Cafe 2, which is another deep learning staple, as you call it. Which Cafe 2 is different than TensorFlow. How?
It's a different framework. This one developed by Facebook. TensorFlow is developed by Google. So it's a different. It's different code essentially. So they're both Python programs, and you're calling either the Cafe 2 or the TensorFlow framework, and then their own code paths essentially. But they're trying to achieve the same thing. In this case, training a neural net with the ResNet 50 model.
Got it. So again,
similar stuff
here. We go from 274 images per second up to 553 peak, right? With the Titan V. So, this is the beginning of us figuring some of this stuff out. I think it's a really good beginning step of how do we measure machine learning. We've already been reached out to by several different people, like, hey, I have these things I like to benchmark. Here's how we can do this. We've had conversations with people at NVIDIA and starting those conversations with AMD about how to test this stuff going forward. And it really made sense that we needed to get to this with the Titan V because it was its primary focus.
Yeah, when you have fixed function for a certain task, it usually makes sense to test that.
Josh, do we know how much of the die is actually like taken up by these tensor cores? I'm curious about that, right? Because if you look at it, like the tensor cores, if you look at this metric here, are running, almost 100% faster, 80% faster than the FP32 cores, the standard CUDA cores, right? Is this indicative of, hey, as it turns out, fixed function units are going to be, or maybe closer to fixed function units are still going to be better for this, and it give credence to the idea of Google's TPU that they're building versus continuing to push in on GPU-based machine learning models?
How many questions you want to ask?
Just three.
Many. Okay, first of all, we don't know how much the tensor cores take. Secondly, you're absolutely correct. They're not exactly fixed function units, but they are more simple in how they handle math than floating point.
They're more
or,
specifically tuned,
GPU
I guess I would say.
Yeah. And so, because they only do a certain amount of operations, you can make them smaller and you can have more of them without impacting your TDPs and die space. And how important this is going to be, well, it depends on where the market goes, because the stuff that they're using now for driving, automation, just understanding, hey, some security camera sees there's a guy in a crowd that pulled a gun. They're going to identify these things. Even with the group that I work with West Incorporated, we started using TensorFlow for dolphin analysis. So dolphins all have, just like killer whales, they have different dorsal fins. And so we're using TensorFlow to identify individuals so that when somebody takes a picture out in the Gulf of Mexico and they post it on Facebook, and then we could possibly grab that, we could say, hey, that's, specimen 1A 1999, whatever.
Oh, sure.
These things are becoming far more common because images are everywhere. And just ask the social media people. Just ask those Snapchatters who are posting 500,000 selfies over a couple of years, what image recognition will do. And TensorFlow is, Tensor cores are outstanding for this kind of work. Yeah. So there you go.
And I know one of
the my kid coughing in the background.
That's okay. I'm doing it on the side of the call too. So
yeah.
When we were looking into this and asking some people at NVIDIA, Ryan, I know one of the few sort of technical details we got about these Tensor cores is that they can do 64 FMA per clock. So that's a very deep, is that deep or wide?
Wide, I would say.
That's very wide.
Yeah.
In the grand scheme of things, compared to something like a CUDA core doing this math.
Yeah.
I believe.
And you said FMA, that's a fixed point multiply add?
Yes.
Used multiply
add. Yeah.
Something like that.
What's interesting is the reason the way I posited the question to you before is like a lot of people have been saying, NVIDIA's been riding this wave of machine learning up to their current stock price, and now it's just like, okay, Google's now buying engineers up from people.
Google's on their second generation of Tensor.
Right. So will NVIDIA have to get away from using the GPU for machine learning if they want to continue to make machine learning their thing, right?
Yeah.
And it seems more like
they can just throw out another SKU.
They could, but what I was getting at before was like the die
they
sizes.
Have fewer GPU cores and then rack up the Tensor cores.
But at what point does it make sense to just have Tensor cores, right? If you're only doing compute for these specific models, right? Like I'm trying to figure out what the performance per square millimeter die is on those Tensor cores versus on the CUDA cores, and then how do you balance that going forward if you want to make Tesla, machine learning specific products?
I think a lot of the issue is that they don't exactly know what the final form a lot of this stuff will take. So and there's still so much research going on.
Not even my final form.
There's still so much research going on that maybe we discover tensors aren't the appropriate thing to use from a mathematical perspective. So you don't want to go full into tensors.
That's the bad thing is like, hey, I'm going to design an entire tensor core, tensor thing. And suddenly someone comes up with an algorithm that will actually utilize, something a little bit more general. Yeah. And so I think that we're always going to have a balance of, more general processing cores with specialized tensor cores, because it just kind of makes sense that way. People are going to do interesting things with software. Yeah. And the more flexibility you have in certain situations, the better off you're going to be. Because not everything is going to be, I'm going to identify this. I'm going to identify this. I'm going to identify this.
I feel like we're within reaching distance of a point where like audio processing became very fixed function, right? To the fact where you have these extremely low power phones that now have fixed function audio to listen for keywords that, do all these things that that I feel like for the vast majority of the machine learning stuff that we're doing, we will find that answer. And at that point, now what do you become, right? So that's got to be NVIDIA's risk in all of this, is that becomes the thing. Somebody like Google or Facebook or whoever decides to make their own chip. ARM makes some variant of it, and now,
if you look at
here's the problem with that.
Doesn't help anymore.
You're addressing one area, and say somebody wants to address 3 other things in one photo. So you're not just identifying kind of one thing. Maybe you're going forward and identifying behaviors of people that are in the photo.
Yeah.
And so you've got a whole lot more complexity.
What I don't know is if that would equate to different processing models or not, or if it's just the same processing model with a different software layer on top of it, right? Like that's what I don't know. Like we look at these these particular learning, neural networks and stuff, and how what percentage of machine learning is based on these 2 or 3 specific models, right? And my guess would be it's pretty high currently. Will that change?
Okay, when has data and computation ever just stayed the same in the past 30 years without people adding to it or doing things to it?
I gave the example of audio, and I would posit that that's a pretty standard one now, right? Graphics is still changing somewhat, but I can't think of any other examples.
Looking at this another way, your argument is that NVIDIA is built around, part of your argument is that NVIDIA is built around GPU expertise, and what happens if we don't necessarily need GPUs for deep learning anymore?
Yeah.
I think what you're discounting is NVIDIA's software expertise and the sort of stranglehold they have over everything with CUDA right now.
Yep.
So they still own the software stack. So if they can iterate on fixed function hardware and integrate with them, integrate them with GPUs, or release them as additional products, whatever they do with them, then I think as long as they're keeping up with the pace of that stuff, that their current strangle on the software ecosystem will still help them. Because I don't think
I agree.
I don't think Google is ready to reinvent the wheel necessarily. They're just they're happy to use CUDA as a platform.
I think they pretty close.
They absolutely could.
Because that would be my next question was going to be like, how many companies do you think will actually at the end of the decade have input on machine learning? Is it going to be 5 companies that essentially control all of that? Google, Facebook, Apple, whatever, right? And if so, then they're probably going to be more willing to go their own way than if there were 100 companies that needed to do this stuff on a large scale, and in which case NVIDIA would potentially benefit greater from that.
Yeah.
Right? But I don't know. At the end of the day...
let me ask you this.
Oh, okay.
Okay, have you watched Dark Mirror, any of the episodes?
No.
Black Mirror?
Black Mirror, yeah.
No, still no.
I've been meaning to.
It's going to be a good story.
There was one that they basically recorded a woman for a week, 2 weeks, whatever, and then kind of translated that into an AI program, and they kind of whipped her into shape so that she would do the things that AIs would not necessarily do for that individual. Like, this person likes toast a certain way. This person likes these clothes in a certain way. Things that AIs can't do without a ton of training. And so my point here is we don't know where this kind of learning is going to go. I mean, I'm not saying that NVIDIA is going to, brain scan you and, get your preferences for every damn thing.
Sure.
But I'm talking about these are new problems that they're looking for solutions for, and it may not just be these tensor cores.
Yeah, no, you're right.
So does that make sense?
I mean, it does, but everything we're saying is may or could or might.
Absolutely.
Right, and I don't think any of the 3 of us are experienced enough in the machine learning fields to make. You did set up an NVIDIA cloud client. I get it.
I ran these benchmarks. I understand.
It's really just to define the future. But we've talked about that for much longer than expected. But hey, it was a short episode, so I figured
I can already see picks of the week on the rundown.
It's true. It's true. Before we move on to the next story, we did have 3 Patreon updates. I like this one. Witches Be Crazy just pledged $27. So thank you. Awesome. Witches Be Crazy. I like that one. Lou Skunts just pledged $3. And Chronarch edited their pledge from $7 to $8.
Nice.
So thank you guys, all 3 of you, very much. Super, super awesome.
Very nice.
All right, real quickly, Lee posted a review of the Seasonic Prime Ultra 850 watt titanium power supply. So if you want Ultra and titanium in the same power supply, I'm not exactly sure what that entails.
Could we fit like a Max in there somewhere, maybe?
That's probably what they're going to announce at CES.
Sweet.
It's the Ultra Platinum Max Plus.
Titanium.
Yeah, so it's a titanium level efficiency, which is the 80 plus organization's highest rating, which obviously doesn't make a lot of sense anymore because it's like 90 something, was it 97% efficiency or something for these units? Fully modular at that. This is available in 1000, 850, 750, 650. It's an impressive looking beast for certain.
Well, scroll up a little bit.
Okay, yes.
Wow, look at those cables.
Ooh, flat.
Just like a connectors of wires coming out of there.
It's not a mess. It's clean and neat and well.
No, mass.
Yes. No, I'm with you on that.
Yeah.
I'll agree with that.
Isn't Seasonic the guys that only just recently went to digital power control?
Yes.
That's the Prime
was the first one that did it. Yeah. So and they announced that at last year's CES is when I think they showed it to us the first time.
Yeah,
I think that's what it was. So
they did pretty good with analog for a long time.
They did.
I think they're doing pretty good with digital too.
Yeah, and
they seem to be.
They, at the time, they basically came to me and said, we didn't want to make the switch until we were sure that the digital would meet the same quality as our analog, right? And we went through a lot of this stuff with the tolerance load regulation that they have implemented and that type of stuff. These are impressive power supplies. They're not cheap. Don't get me wrong. Although it does have, let's see, 6 PCIe cables, right?
It's not nearly enough for Alan.
That have 8 plus 6 on them. Oh no, this is only the 850 model, right? So
scroll back up. Scroll back up.
Yep.
Is this the Cthulhu edition? Elder gods come to
let me
power
look at them
PC.
Caps.
Hope your cable routing is good.
Those caps are acceptable.
Caps with barcodes are always a good sign.
You can really tell if there was a blown.
Yeah.
There was a nice thing on the previous page. It comes with an ATX tester.
Okay.
It looks like.
Yes, I did see that.
So this is for Bitcoin mining then.
Well, nah. So what was the review like? Editor's Choice Award. Weaknesses, none noted.
None.
Ultra high efficiency, 80 plus titanium. Quiet, high quality 135 millimeter fan with fluid dynamic bearing. A 12-year manufacturer's warranty.
Wow.
Multi-GPU technology supported, dedicated PCIe connectors, fully modular cable. Now, this is a $209.90 MSRP power supply for the 850 model. That's $259 for the 1000.
That's up there.
So that's obviously expensive.
But 12-year warranty.
But a 12-year warranty. Yeah.
You're
going to replace every single other goddamn part in your product in your computer.
Maybe not your chassis.
Before that runs out of warranty.
The Prime Ultra series, which is this one. Let's see. Let's pick
my
a time.
computer's one is updating right now.
Let's pick a time of not now. Tomorrow.
I usually go to the bottom of the list.
Why put it off today when you can put it off?
The Prime Ultra series uses an upgraded fan with lower max RPM for very quiet operation.
Yeah, apparently this can do the stuff where if it's not drawing a lot of power, it will just turn the fan off. It has like the hybrid fan stuff.
Got it.
Which
So Editor's Choice Award, that's a good thing from Lee. As we are still one of the few outlets still doing dedicated power supply reviews. Very, very much worth checking out.
Because we care.
Because we care about your power needs or something to that effect. All right, next, ASUS ROG Strix GTX 1080 Ti.
Take it away, Josh.
Review, top of the pack.
So here I reviewed everything.
There it is.
I give it the Kitty Award because
is it good? Get a good
so
award?
soft
and fluffy,
right?
This card, so Josh's review of the ASUS ROG Strix GTX 1080 Ti is that it is soft. I'm not sure that's a positive. I'm not sure they would take that.
And it's got a motor running all the time. Otherwise, it purrs constantly.
So, okay, as it turns out, Ken is the one who actually did this review as well. 1080 Ti, overshadowed by the Titan XP, overshadowed by the Titan V. Still flagship GTX branded card, kind of non-Titan card. I
think I called it like the highest performing gaming GPU.
Okay,
because obviously when you can game on both Titans, they're not exactly targeted towards gamers.
Yeah,
like enabling the professional workflow.
I would say the Titan XP
Yeah, but they enabled the Quadro features in the driver, which makes it a little more professional oriented than it used to be.
They also made Star Wars editions to go with the Battlefront 2 release. So it's kind of like, you can't deny the gaming culture.
I'm a Star Wars researcher.
I'm a Star Wars rendering fan. Yeah. So anyway, the GTX 1080 Ti actually launched like back in March.
Yeah,
I think it was.
Yeah,
we're almost on a year, and that was launched like 7 or 8 months after the GTX 1080, right?
Oh, like 12 months.
Yeah.
No, the GTX 1080 came out like in June.
So would you say that the
like
1080 Ti is the most significant GPU launch this year?
If the alternative is that or the Vega 64.
I mean, Titan V.
Yeah.
It's kind it's not very significant.
I would still have to say
it's significant from an interesting perspective.
I'd still have to give it to 1080 Ti because it's still the leader in performance. It was the leader not by a small margin when it came out.
Yeah.
Right? The Titan XP came out and kind of stole some of it, but it is a $1,200 MSRP instead of a $699
You shouldn't buy Titan XP.
But you shouldn't buy that if you can.
Only idiots buy Titan XPs.
What about ones that look like Darth Vader?
No, those are cool.
Oh, okay.
We should buy all of those.
Good. Great.
Still available as every time I install the driver, it likes to advertise to me.
Yeah, that's true. This is, by the way, so the ASUS ROG Strix that we're looking at this is it in comparison to the reference design.
It's huge.
It's longer, it's taller, it's wider.
It's
all the things Josh looks for.
1.23 inches longer, 0.9 inches taller, and takes up an extra slot. They call it a 2.5 slot.
The only thing that I look out for anymore is if the liquor store handles
handles. Yes. Continue thought.
Old Speckled Hen.
I don't know what is he talking about.
It's the only joy. It's the only joy in my life. Old Speckled Hen.
Anyway,
I had it on tap once.
What is
it was life changing. Life changing.
What the? You on cough medicine?
No, that would be my child. One day he will get over his cold.
Ken talked about this in the review. The Strix brand and the Matrix brand kind of merged. They only had one.
They destroyed the Matrix brand at the 10,000 series launch, but I didn't necessarily realize
1,000 series.
The 10,000
not the 10,000 series.
Whatever.
So they merged some of the same feature sets too. Like this has
Strix kind of used to be
fan connectors and stuff.
Strix used to be kind of middle of the road, and now it's the highest end option. And it's not like they just took out features; they gave Strix way more features,
right,
to make it the flagship offering.
It's got LEDs,
pretty tasteful RGB LEDs.
RGBs. It's got the fan connect.
Yeah, I really like the fan headers where you can hook chassis fans up to your graphics card, so they're sort of follow the fan curve of the GPU. So if you have front intake fans, which are providing air directly into your GPU,
sure,
then you could hook them up to that and not necessarily have to worry about all this custom fan tuning software and all of that stuff.
2 8-pin power connectors, beefy ass heatsink with heat. How many heat pipes? Did you count the heat pipes?
6, I believe.
6 heat pipes.
It's a lot of heat pipes. It's heavy.
It does have DVI output. Somebody in the chat said the only question is, does it have DVI output? The answer is yes.
I had a reference to an ATI earlier this year in my home PC, and I have that Korean monitor. The only thing it has is dual link DVI.
Yep.
I was severely disappointed.
Yeah. So because it doesn't have a blower style cooler, it doesn't need the extra exhaust vents for it. But like, I mean, look at that picture. Look, the mounting bracket for it just makes everything else enormous.
I don't like the trend of very tall graphics cards. I think long is fairly fine as long as you're not getting to 14 inches long.
Yeah.
I think 2.5 slots is all right because anyone only usually puts one add-in card in their machine. If we're talking about the vast majority of people, maybe you have an SSD or a capture card in there, but you can space that out. But the tall really starts to limit you. Like I have a Corsair Carbide 200 or whatever, 240 Air 240, which is the MATX one. It has a very it can hold a very long one, so to speak, but it has room for a very long graphics card, but the clearance to the side window is absolutely nothing. You can fit like a reference NVIDIA cooler in there, but nothing else.
Got it.
So it's disappointing to see cards like this that are super tall and kind of aren't accommodating to a lot of those form factors.
In terms of what we evaluated, so we've already looked at 1080 Ti performance. It's a well-known thing, well understood. So we looked at things like sound levels. It's a very, very quiet card. That massive heatsink dissipates a lot of heat, means the fans don't have to spin until it even gets to like 58, 59 degrees Celsius.
It's 55.
Is that what they say?
55 is the number.
When we were watching the temp go up, it didn't turn on. The fans didn't turn on until 58, 59. But it might just be on how it's being monitored
at that point.
And even when they are spinning under full load, it's at 34.5 dB, which is near our sound floor at the office, right? It's, within
we don't
2 or
get
3
much
decibels.
lower than that.
You compare that to the 1080 Ti, Founders Edition, 39.1. You compare that to the Vega 64 Air, which is 46.4 decibels. You have, so what is that? Every 6 decibels is a doubling of noise level, right?
Yeah.
So is it 3 times as loud? I don't know. I don't want to do that math. But it's very quiet graphics card. In terms of clock speeds, it actually runs really well too at stock.
1923 is what it was.
1923
maintaining.
Stock. So no, I guess you should point out it's the OC model.
This is the OC model. They sell a not OC model, an OC model for some stupid reason. Just two SKUs to have in the channel.
And the difference is like
$10.
Yeah, and it's like 10 megahertz or something like that, right?
I didn't look at the actual.
It's like 10 or 15 megahertz. It's a useless thing.
You're gonna just take the sliders in GPU Tweak 2 or whatever Precision X OC you're using anyways. Yeah.
So it's interesting. So it leveled off at 1923 megahertz, and the temperature was like 64 degrees Celsius. So well under where your reference / Founders Edition cards go. We overclocked it with a plus 70 offset.
Yeah, this is a very quick overclock.
Yeah, I mean,
just to see if there was additional headroom to get.
And in which case, we were now running at over 2 gigahertz.
Yeah, 2023, I think, is about where we
and our temp
maintained.
Still only got up to like 67 degrees Celsius.
Didn't really get any hot.
Yeah, so we went from 1881 average, that includes the
ramp up.
The ramp.
Yeah.
Up to 2024. So our average clock speed was 2024 after just moving these sliders over. Pretty impressive stuff. Power consumption wise,
hey, guess what? It uses some more power than the Founders Edition.
It does, yes. But about 20, 30 watts or so more than the Founders Edition.
Still less than the Vega 64 air-cooled cards, the reference cards.
Yeah, it is.
I mean, it was a little under 300 watts. I'd call it under 300 watts is what I would call it.
Yeah, that's fair. And the Vega 64 Air's 300 watt setting is probably 5 or so watts higher on average than that in our testing. So interesting look at stuff there.
Shouldn't exactly be a surprise if you're looking at this graphics card.
Yeah. And from a performance standpoint, it's slightly faster than 1080 Ti.
Yeah.
Right.
So Grand Theft Auto 5 doesn't really show any gains. It's still a very CPU bound game, even at 4K, which is crazy. Hitman, we saw like a 7 or 8 FPS difference, which is actually pretty good.
Yeah, and all this testing was done at 4K.
Yeah,
because we thought that's what made the most sense.
It was hitting 82, 83 FPS at 4K. So I mean, testing lower.
And The Witcher 3 was hitting just over 70, right? So it took it from like 68 to 72. Moderate increases over a reference Founders Edition, but you're doing it at a much cooler temp, much quieter sound level. Now it is expensive though.
Yeah, but it's less. I'm going to say it's less expensive than it used to be, which isn't true. But the Delta is less expensive than it used to be. So reference costs for a 1080 Ti should be $700. Currently, the cheapest 1080 Ti I could find on Newegg was a gigabyte blower design, which wasn't the Founders.
Wasn't the Founders Edition.
Wasn't the Founders Edition. Was their own blower cooler. It was $740. And the non-OC version of this, which is the only one in stock, came in at $800. So that's a $60 difference.
Okay.
However, the MSRP of this card is supposed to be $780. So the markup isn't as high as the markup for the lower end, if that makes any sense. So if everything was at MSRP, it would be an $80 price difference. Now it's only a $60 price difference. So it makes more sense to go from blower to go to this triple fan setup with more features and more overclockability, quieter. Yeah. Depending on your case, I mean, blower.
Obviously, it's still a lot of money, but I see the argument there of it just being
If you were going to buy a $700 GPU, you could probably buy an $800 GPU.
Don't be such a cheap ass, Josh. Spend the extra $100.
I say this as
Dude, I've still got medical bills to pay.
Yeah, but you're not going to buy a $700 GPU.
Kids coughing in there.
No, we don't care.
I'm gonna pay a surgeon and an anesthesiologist.
You don't need anesthesia. Pass that part. Go straight to the surgeon.
You got bourbon,
only.
right?
It's fine.
I just got to get a $15 hammer from Ace.
15.
Knock him out.
That's a little much, but
you don't need a quality hammer to knock someone out.
All right, let's talk about a couple of other things before we get to our picks of the week here. One, this was a news story that kind of cropped up through the day today. NVIDIA, this is a CNBC story, which we don't put on here a lot, but CNBC.
I mean, it showed up in the, on Reddit a couple of days ago.
Oh, was it a couple of days ago?
At this point, yeah.
NVIDIA made a change to how it lets developers use its chips, and some folks aren't happy. So,
number one, the photo of that is a car part, which doesn't apply to any of this.
That's true. He is showing a Drive PX or something like that on that system. So essentially, what NVIDIA did was they updated the EULA for their driver, right? Because it's the only place where they would be able to present a EULA, I guess.
For the driver download.
For the driver download, before you can start to download it.
Which is different than the driver install, I would imagine.
I guess, I don't know.
Because the download EULA has a lot of references to downloading the driver as opposed to installing the driver.
Got it. Mm-hmm. So the update, quoting here, which was made when NVIDIA introduced the Titan V GPU earlier this month, is intended to deter the use of those GPUs inside data centers. So basically, the EULA is changed in a way to prevent people from using Titans or GeForce cards
for GeForce cards.
It doesn't say Titans?
It's the GeForce driver EULA, but Titan cards are still GeForce cards. They're not GTX cards.
But it's the same EULA that pops up.
Yes.
Okay. To prevent those cards from being used in data center implementations, insinuating that you should use Tesla, I guess, not Quadro, but Tesla cards in those situations. It says the change does not apply to NVIDIA's Tesla line of GPUs, which are available from cloud providers like Amazon and Microsoft.
And they explicitly permit blockchain operations.
Yeah, that one's a little odd. They do say, with the exception for blockchain operations, it's okay to use GeForce GPUs for data center-based blockchain stuff, which I think is maybe because they realize there's hundreds of thousands of video cards out here on the wild in data centers running blockchain and cryptocurrency mining. So they had no choice but to do that. But so they talk about Reddit, trying to make sense of the language. Some critical responses allege that NVIDIA is making the change to compel customers to use more expensive Tesla GPUs instead of lower cost processors, which it absolutely is doing. It's not alleged. That's why they would do that. An NVIDIA spokesperson in an email highlighted several reasons that companies would prefer Tesla GPUs in data centers that include support, longer life expectancy. But this is kind of interesting. The email said that if customers want to use Titan or GeForce GPUs in data centers, they can talk with NVIDIA's sales department. We expect that working together with our user base on a case-by-case basis, we'll be able to resolve any customer concerns, which I can imagine that being anything from discounts on Tesla cards to make them more affordable and more appealing instead of you buying a bunch of Titans, or okay, we'll let you do it this one time. Here's a release form of something. So you were particularly interested in this discussion, I guess I would say.
What? No, me? Never.
So the debate is, why would NVIDIA do it now?
Well,
and what is the risk of them doing it? What are they attempting to do?
I don't think anyone would debate why they're doing it and the sense it makes to do it. Obviously, they don't want people filling data centers full of 1,000 Titan Vs instead of buying Tesla cards.
Right.
That makes sense to everyone, I think. However, the sort of sticking point I have is that they use this term data center, which they don't define anywhere in the EULA, as you might normally expect with the contract, that they define certain terms as they go along. That's, if you've ever read through one of those things, that happens. So I have a feeling that education is kind of the part that would get a bit screwed here. So if you're a mid-sized university with a small CS department, it's not an area that you sort of focus on, and you want to buy 5 Titan Vs and put them in some machines so that students can use them to train, or researchers or professors, whatever, can use them to train.
Right.
How do you know that what you're putting them in is not what NVIDIA considers a data center?
Sure.
So like when I went to UC in the CS department, they built a sort of a cloud where you could kind of section off some stuff if you wanted to like run a web app and you just needed a development environment, and so that they could teach OpenStack for like open source virtualization stuff in the field. And that was maybe 2-3 U boxes in a rack with associated switches and stuff like that. Is that a data center? Like if they wanted to put a Titan V in there so that people could use it for deep learning projects, is that against the EULA? Is that a data center? Right. It's just these weird gray lines that I don't like about it. I wish they would have defined the term.
Yeah. When Jim came up with the thought process of like a data center is like art, you know it when you see it, right? And in that way, it sounds stupid, but I kind of agree, right? In that if I see, you know, a hodgepodge rack with 2 video cards in it and cables all miswired and you know, power running from 3 different outlets because they didn't actually have power run for the system set up correctly. You think, okay, you know what, I'm going to let that guy go. If there's 3 full racks and there's 40 GPUs in there or 60 GPUs in there, and you go, okay, maybe now we'll have that concern. Now that is a problem for NVIDIA because now they're kind of going to be in this policing state. I would argue that they probably have no interest in pursuing any of this, with the exception of the super highest end customers, people who are trying to buy 1,000 Titan Vs for $3,000 instead of 1,000 Tesla V100s for $9,000, right? Because now all of a sudden the difference is $6 million in income. But I think people, if you're using 10, 20, 30, it's probably not even going to be an issue there. Why they wouldn't define that specific number seems reasonable to me because they don't want to have to stick to that number. Right? Because
that number is a moving target.
Well, like I said before, it's like if the number is 20, well, then you buy 20 and I buy 20 and Alex buys 20 and now we have 60. Right? But they're all, it's 20, it's 3 different organizations. Can we get around their loophole that way? It's
in the same point.
But actually, I was bringing up something before you move on about like when you were setting up that cloud infrastructure. If you're using a Windows environment for that, right? There are some features that you have to have a Windows Server edition to get some, you know, storage array capabilities or something like that. Regardless of whether or not you're running it to attach to 1 computer or 50 computers or whatever. Right. But, so there's precedent for like.
But this isn't like an additional driver that enables deep learning. It's the driver.
Yeah, sure.
Like if you didn't want to do deep learning, if you just wanted to, I don't know, let's say I'm a student organization and we got some funding for some reason and we wanted to fill a couple racks full of machines with 1080 so that people could come in and use them. Right. And rack was just the easiest way to organize everything. We've got like KVMs run or whatever. Is that a data center?
I don't know the answer to that, right?
My problem is sort of the moving target. If they don't define it, then they could just I don't think they're necessarily going to. They could just suddenly come to you one day and say, you're violating our EULA.
They could.
We didn't think you were yesterday, but today, we have determined you're violating our EULA.
As we were talking earlier in the studio, all the issues with this gray area could have been resolved by just a slight change in terms. You know, don't say in a data center. This is retail product. This is not enterprise product. There is no warranty or guarantee for fitness in an enterprise environment.
Well, then you have to define enterprise environment in the same way you would define data center, right? Because their claim is that, you know, NVIDIA addresses the unique mechanical, physical, management, functionality, reliability, and availability needs of servers with our Tesla products, which include 3-year warranty covering data center workloads, NVIDIA enterprise support, guaranteed continuity of supply, and extended SKU life expectancy for data center components. This has been communicated to the market since the Tesla products were first released. But they're not just Titan and GeForce do not have that.
They're not just saying that if you do this, we won't support you. They're saying you cannot do this, which is a difference.
Yeah. Does you breaking the EULA of your product then give them the legal right to void your warranty in some case? Maybe.
Well, absolutely. I I don't know. But
is that what they have to do to make your warranty void?
So if you look at the EULA and you look at the terms, if you violate the EULA, they say you must delete the software from your computer, so you cannot use the product. So sure. They could have warranty terms that say something like, if you're using this for data center applications, then your warranty is void. Maybe. I'm not entirely sure what warranty law is. That
sounds like something that would be illegal in the US
versus it's definitely that wouldn't be legal in the EU, I would imagine.
Right.
But so I like the warranty and the product are separate things.
Yeah, but I think the warranty issues are interesting because some states don't let companies void warranties.
Yeah, I think that's all.
Right?
Also
that probably has something to do with it.
Point.
But to me, it's in there to protect them if they feel like they're being taken advantage of.
Sure. Right? I absolutely understand why it's there, but I'm not necessarily okay with that.
I still support the release of the Titan V. I still support like what the intent was, right? The intent is for a guy who has an idea to be able to have the best, most performant machine learning GPU on their desk to use to prototype, to develop and create these products, right? It's for me as a company to buy my 10 top engineers for their workstations so that they can create the best products. But it's not intended for me to deploy on a 1,000 card level into a server environment.
Sure.
Now, I think if it were possible for NVIDIA to just go, like, if you do that, like you're on your own, like warranty void, no support, whatever.
That's probably sticky enough in a bunch of different territories. That's not necessarily possible.
Now that I think more on it, that's probably what they wanted to be able to say, but maybe they couldn't say legally because of EU restrictions or other stuff.
Yeah, but I don't know if the type of person who would like kind of go subvert around this stuff and launch a data center with 1,000 GeForce cards instead of Teslas would care about their warranty. They would like you could buy two Titan Vs for the price of one Tesla V100.
Right, but
so do you care about your warranty then?
If you're deploying at that level of scale, you're gonna pony up the extra cash.
I'm not talking about proper deployments. I'm talking about kind of shady operations.
Right, but if you're a shady operations, are you gonna be looking at the EULA anyway?
No, you're not.
I mean, do you care?
I would argue that if you're deploying something, it is to sell something or offer a service, and so you would care about that availability, support, uptime, thermal guarantees. Even though, like, I'm sitting here, I don't think there's a drastic difference between the PCB or the chip or the integration of the Titan V that there is on a Tesla V100, right? There's a cooler, obviously, integration difference because of
well, I don't know what the add-in card looks like. For
it might be similar.
It's probably,
but like I've never been somebody who says, "Oh my gosh, the Quadro is such a different card than the GeForce," right? It's clearly not the case.
No,
and the same thing for Tesla, to be fair. But those are the it's just like in the beginning days when you had to hack a text file to get Adobe software to recognize your GeForce GPU instead of your Quadro GPU, right? And you had to do that for some period of time, and then they eventually just added support in for the GeForce GPUs and went about their business.
And the other interesting thing about this is, I think it's mentioned in the CNBC article, is that it only applies to drivers going forward. So I guess it might have applied to a driver that came out on the 20th, which means that if you want to do deep learning at data center scale on a Titan V, there is one driver you can use.
That's true. You can still download that driver or have that driver.
Yeah. Which is interesting because I don't think the TensorFlow performance isn't going to change at all.
I would bet the next revisions of the containers don't support that driver.
I don't know if that's a thing you can do, but that's fine.
Oh, well, or
I don't know what the Docker calls the host OS look like. I mean, that's a whole separate thing. But
fair enough. All right, let's get into our last story. Jeremy wrote this up, but he's not here. Wait a minute. Why isn't he here?
He's flying home.
He still wrote the story up today. Good for him. Okay.
Yeah.
Where was he at?
He was
in Montreal, wasn't he? Yeah.
At home.
AMD a little too far ahead of the curve again. This was a Digitimes story. What were we looking at here, guys? This was them integrating technology too early and kind of suffering for it. Is that what this was about?
You should click back through the article to see if they fixed any of the typos in it.
There were a significant number of typos on this piece.
They called Vega. What did they call it? No, they haven't fixed any of them.
No.
Radeon Vage.
That's true. Where's that at? Yeah, the Radeon Vase chip.
And HMB-based products.
HMB-based products. So this is basically telling us that, remember the hybrid memory cube? Those are things we were talking about last week. Yeah.
Yeah.
They use a similar vertical stacking process. What is this telling me? Well, I didn't read this beforehand. This Jeremy
it's just that HBM has been increasing in popularity, I think.
They are indeed, and being applied to different products. The Nirvana chip from Intel is using HBM2. Apparently, a lot of networking controllers use HBM. At least they did the first generation of HBM. I don't know about HBM2.
Intel announced an Altera FPGA with HBM2, I believe, on it recently.
I will give Joe Macri and the guys at AMD a lot of credit because they saw it coming. They saw this coming. They told me this was going to happen. Like, basically, the premise for when there was a lot of crap coming on about Vega using HBM2 and the cost of HBM2 and whether or not they should have gone with GDDR5 or 5X instead. Macri's stance to me was that we believe in HBM as a memory technology, HBM2 as a memory technology, and we knew that if there wasn't a high volume driver for it, like a consumer graphics card volume driver for it,
would never get off the ground.
It would never be developed.
Yeah.
Or it would never be developed enough to be useful for them in the next generation when they needed it. And everything would slow down because NVIDIA had been shipping HBM2 parts, but only in Tesla V100. Only in super high margin, they sell them for $9,000 a piece, as we've just been talking about. They don't have to worry about what the cost is, or what the margins are that Samsung is making.
The GP100 was also HBM.
Yeah.
HBM, I guess it was HBM2. It wasn't HBM1, was it?
I don't know the answer to that. I don't know. So now we're starting to see the other chips using this, and SK Hynix. Did they say SK Hynix? Is actual in production yet? They don't say specifically. I know last time I had this conversation, SK was still
ramping up
in the beginning stages of actually offering availability, which would be a big increase for it. Now, obviously, for Vega, it's a little bit too little, too late, right?
Yeah.
Like it missed its way. It missed its chance at opportunity to be a successful product. I don't think the memory technology was the reason for it being or not being a success. Except for maybe a success from like profits on an AMD standpoint.
Yeah, because it still costs a little bit more money to implement an HDBM solution.
Correct.
But if you think about it, what's coming up soon that doesn't use an interposer?
CES.
Other than CES.
You're talking about Kaby Lake G?
Yeah.
Yeah, that uses HBM as well.
It has to.
It does.
I'm really curious what its what its run will look like. Like, how many of these processors is Intel going to make?
Not a lot.
I don't feel like it's a huge number. I would like for it to be a huge number. I think it's actually a really compelling product.
I'm excited for it.
Do you think it's going to be 30,000 to 100,000 or more like 1 million?
I would go with the first. That's more towards the first estimate. It's a very niche product.
Here's what determines what that answer is. Does Apple use it? Does Apple decide in their next MacBook Pro that they don't want to use a discrete chip anymore? They want to use this integrated, Intel part. That will be a big determining factor because not only does it drive
that's such
Apple
a compelling
sales,
part for them. They have to use it, right?
Not only does it drive Apple's margins,
they're gonna use it.
It will drive interest by the other OEMs to make sure that they're not missing something and being left behind, right? And so your Dells, your HPs, your Asus, they're all going to integrate a part based on this. My understanding
I think it's going to be bigger than you think, Ken.
I hope so.
I think that it's going to think.
I hope.
Yeah, no, I mean, it's so nicely integrated. It's such a small overall part.
But how expensive
and it just is so logical.
The interesting question.
You've got a Retina display of many thousands of pixels that you want to have 3D content on. You want to do potentially some VR things. Some basic stuff maybe in the future that Apple may or may not be doing.
Yeah. So how expensive do you think this integrated solution would be versus like integrating a mid-range NVIDIA GPU into your product? I know that's not really an estimate that we can make, but do you think
initially it's going to be expensive? But once they start ramping up and HBM2 memory becomes less expensive and they figure out more of the issues of Intel's, because it's not a full interposer, it's their, I can't remember, SMIC, what?
SMIB. SMIB.
Yeah.
Yeah. And once they get all of that figured out, it's not going to be.
I think that
and I mean you're gonna have less chips, you're gonna have less PCB complexity.
Yeah, it absolutely makes sense as a product. I just think that if Intel's a little shy on it and isn't super aggressive, then it will be such an expensive part to begin with that no one will integrate it, and it'll be sort of a snowball effect.
It's EMIB, by the way, embedded multi-die interconnect bridge.
The other one didn't sound quite right, but I didn't know what it was.
Yeah, I think the EMIB is a really, really interesting part of that.
Absolutely.
I'm also really curious. I want to make sure this is yes. Intel is also going to be responsible for the entirety of the driver stack in this product, right? So there's still some questions about how that's going to work. And
Intel's responsible for the driver?
Yeah. Intel is.
So basically, AMD is going to open source their latest driver to the Intel driver team.
I would say.
Or are they going to deliver binary blobs for like the graphics guess. Portions that
I would guess that AMD basically provides them their driver block as they go, but it's up to Intel's team to package it, release it.
Man,
so there's questions behind that, right?
How fast are they going to be at that?
I have told them several times that they need to be very fast.
Yes. Look at how current Intel graphics driver support is.
Exactly.
Wait, I don't understand what argument you're taking.
Yeah,
that's what I'm saying. So that needs
That's
to be
why they need to be way better at this if they have a part that can actually do something.
Exactly. I would agree with that.
Yeah, but they're forcing software guys to dumb stuff down. I'm not saying it's a good situation, but I'm saying that's where it is.
So what I would imagine would happen is AMD says, hey, partner, semi-custom partner, Intel, we're going to give you, here's our driver for the Radeon. Intel says, ooh, good. Wrap in blue and submit, right? That's what they should do. It should be like a 15-minute process. Replace skin, replace product ID, send out to the thing, right? And they should force all partners, Dell, ASUS, HP, to not require them to distribute the driver. It should be allowed Intel to distribute the driver. NVIDIA has done very good at this, about forcing their partners to let us install GeForce.com drivers on our notebooks. AMD's been pretty good at it, but not
They haven't had much of a chance to be good at it lately.
Intel needs to make that case.
They're pretty up with the Weekle stuff. And so you send your Weekle core to Intel and they just repackage it.
To be installed. Sometimes you want day one drivers that aren't Weekle certified for that game that just came out. Yeah. Right. And that's really what it comes down to.
What's Intel's stance on beta graphics drivers at this point? Do we know?
I don't know if they've ever done anything like that. I will give Intel credit. They have done better. Like I have gotten emails from PR teams about like, hey, we've updated driver to support games like on day one. Like PUBG was something that they kind of mentioned, right? I'm sure it's very, very, very modest support, but they're trying. Hopefully, they're going to take this more seriously. And
honestly, it seems like from everything we've seen, they don't have the corporate culture to do that, to support graphics on the software side seriously.
Brian Krzanich,
doesn't mean that they couldn't.
Came out last week and said what? He said, we're going to take more risks. We're going to take more challenges. We're being attacked from people in different directions. We're going to be a different Intel going forward in 2018.
Easy to say.
Maybe this is a part of that.
Difficult to do.
We'll see systems at CES. I don't know what we'll get in terms of performance or when the systems will actually be available, but we'll see systems at CES. So be prepared for that, guys. All right. Hardware, software picks of the week. Yes.
One more thing on the.
Oh, wait. Hold on. Go ahead.
Josh found a really interesting thing on the NVIDIA side that the NVIDIA warranty terms, as of June 2016, prohibit data center use.
Okay.
So not intended for data center use and/or GPU cluster commercial developments, enterprise use. Any use of warranty product for enterprise use shall avoid this warranty. So that's been in the GeForce warranty clause since July 2016.
Yeah.
So more to think about.
Fair enough.
It sounds like there's nothing really new here with the
EULA thing is different.
The EULA thing is you cannot use our software, which is kind of the only software to use.
Right.
Yeah.
The open source Linux drivers
I would
not.
still, even with that language in place, I would still maybe think that this is their way of solidifying that warranty-less. Because again, the person who's doing something, who's trying to save $6,000 a card, they don't need enterprise support. They're also probably not the ones going, EULA. Oh, cancel the download.
Yeah.
Right. But we'll see. Before we get to the hardware software picks, we did have one more new patron from Todd Hebert. Hebert is a $3 pledger now. Thank you very much, Todd. All right, now hardware software picks of the week. This is mine. Neither hardware nor software. It's a book. I guess there's a Kindle version. Is there? No, there's
not yet for that
hardcover
edition.
Paperback. Hardcover is cheaper. Interesting. So this is Computer Architecture 6th edition, a quantitative approach by John Hennessy and David Patterson. I bought this last week. No, 3 weeks ago now.
Yeah, it's about 3 weeks now.
Because
only $109.
It was $90 when I bought it.
if you round up.
Yeah.
Wait, the hardcover is less expensive than the
significantly less
paperback.
expensive.
Yeah. I don't really get it. Oh wait.
Oh,
What the hell?
Beta edition. What?
This edition is only available from third-party sellers. This is the version they told people to buy to edit, copy edit. I don't
Weird.
know. So I believe it was the first or second edition that I bought when I was in school, right? And this was the book that was my kind of EE base going forward. So I wanted to buy it and see what had changed because they talk about.
Which, by the way, as I've discovered since you've been talking about this book, this is the book.
Yeah.
Like my roommate handed me the 4th edition. He's like, "Oh, I got that book."
Yeah. So this and they've updated it to include stuff as recent as the Skylake architecture. I was a little disappointed on the GPU side. They only go up to like a GTX 480.
I think there's newer than that in there from the
other thing
information I was reading.
The other thing I don't agree with this is they call like big data centers.
Oh no!
Warehouse scale computers.
That's just a that's a term.
That's a term.
That's
I don't like
absolutely
that
a term.
at all. Warehouse scale. So you're telling me if I've got two racks in my corner, is that a data center or warehouse scale?
Lord.
Right?
Like
we're gonna
the
have that
idea
debate
of
again?
warehousing and data warehousing is more of like an IS term than a CS term.
Yeah.
So they do have like putting it all together: embedded versus server GPUs and Tesla versus Core i7. Right, so it's fairly modern stuff, and they give it's still a book, and so it's still slightly out of date. There was a discussion here about storage technology where they talk about Hammer, heat-assisted magnetic reading, and how hard drives are basically dead because Hammer will never really be successful.
Yeah.
Meanwhile, 3 months ago, we went to talk to Western Digital. They released Mammer, magnetic microwave assisted magnetic reading. Wait, whatever it is. Mammer is the abbreviation, the enunciation.
That being said, this was published November 23rd. So if you add in lead time for editing and write this is
brand
still,
new. Yeah, it's brand new.
This is a brand new edition.
And so it is $110. But if it's something you're interested in, even you don't have to be in school for it, but you interested in architectures, and maybe you want to learn about things like XORs, vector architectures, strided loads, compare units, predicate XORs, those types of things. You can do that in here. And you can see from my bookmark, I'm not very far in yet for this one, but I am learning about the MIPS bit here.
So fast.
And if you go to the publisher's website, which is the first result on Google, it's $82.46 for the paperback right now, and they have the ebook for $94.95.
For some reason, this type of book is not interesting to me as an ebook.
Sure.
It's a book I need to flip through. I need to be able to
I wouldn't
look at
mind
diagrams.
having it on a Kindle, I would say, but
you need to be able to scribble on it.
Yeah, not only that, but you can have multiple tabs, sticky notes and areas.
Yeah.
Yeah, but being able to control F through a textbook is also a very powerful thing.
I would like the ability to control F through a paperback.
And this is, since it's from the publisher, this is a ACSM, Adobe content protected stupid ebooks. So you can't put it on a Kindle. Kindle is the one device you can't put it on.
Like, this is actually here's a good machine learning thing for somebody to do, right? This book, feed it into an AI learning platform. So I can say,
that's not how this
talk
works.
to my Echo, and I can say, hey, where's the section where it talks about Tesla architecture memory access? And it would say, turn to page,
that's what an index is for.
Yeah, but like, you don't know the specific term, right? You just know the ideas that the pages we're talking about. This is something that they should do. I'm on it. Anyway, that's a book. That's my recommendation. Who's next? Josh?
Me.
What do you got?
Cough suppressant for child in the background. Maybe even for you.
Got it, yeah.
No, on this trip that I had, what is it? A stitch in time saves 9. So if you were to go to Amazon and buy this charger that flips into your power port and has 2 USB ports into it for $7.50 is so much nicer than the $25 unit you can buy at a gas station because your kids absolutely need it. I think this is a good idea. You just should do it.
Easy to have, 24
because
watt.
Children,
does it get hot? Did you notice if it got hot? 24 watts is a lot for that little tiny device.
Yeah, well, you know what?
Hey,
it's better than nothing.
Not mine. All right.
It's better than $25 for a crap.
Oh, sure. Just like, and those $1 cables they sell on the counter at gas stations that last literally 0 charges. Yeah, those are good too.
Yeah, yeah.
Ken?
So I know you're a big fan of this sort of ecosystem, but the Sonos Play 1, there have been a lot of sales on it recently. This is the best one I've seen. $140 for one of the Play 1 units, which is sort of their lowest end unit. Sonos being a networked audio solution that works fantastically well from what I've seen when you've used it at your place.
Is this the one that they just recently hacked? It'll play nice things for you.
Yeah, there's something about the Sonos API being hacked, but it was like very little units affected. I don't know. I didn't look fully into that. So that could be fun. But networked music throughout your house, being able to sync different zones, it works seamlessly. It's super easy to set up. You can control it by voice from a Amazon Echo now. This is not the Sonos One ONE, which has Alexa built in and will be getting Google Home in the future. That is still a $200 product. But for $140, it's the best price I've ever seen on a Sonos.
Their speakers are surprisingly good.
Yeah.
I have 2 Sonos Play 1s in the house. And they're really nice speakers. Right? Like one's in the master bath, turn on the Moana soundtrack for my daughter when she's taking a bath. And she doesn't complain about the sound quality at all. So that's a good sign at least. But then again, she's also listened to the Moana soundtrack on the Echo Dot. And it's fine with that. And that sounds awful. It sounds like dog poo.
Another cool thing about this stuff is so the Sonos One is, it's a mono setup. They don't shove 2 speakers in there because you wouldn't get any real stereo separation from it.
Yeah.
Anyways, but you can link 2 of them together in their software to create a stereo pair. So if you wanted like a bookshelf setup, you could get 2 of these, which admittedly would be a bit pricey, but you could have both those set up.
Yeah. Yeah. All right. Alex, you got one?
I do. I have been, much to the annoyance of my wife, been rocking out to this band. It came up on Amazon for me about 2 weeks ago. They are Big Giant Circles. It's 8-bit chiptune. And everything I've listened to by them has been pretty epic in the RPG sense.
8-bit chiptune?
Oh, yeah.
I can understand why your wife is annoyed with you.
Yeah. So, but anyway, I've really been digging them. They have all their stuff up on Bandcamp. Check them out. It's like $8 for the album. The red one right below the scroll point's the one I've been rocking out to mostly recently. It's also on Amazon Music, so you can check it out there. So
very cool. There was a comment I saw in the chat that I wanted to mention, and now I can't find it anymore, and I don't remember what it was about. So very cool story, I guess. That's going to be it for us this week, guys. Thank you for joining us. PCPer.com/podcast. You can go there and find download links, RSS files, YouTube links, links to all the stories that we've talked about or discussed. They'll all be included at PCPer.com/podcast. And well, thank you guys for joining us. We'll be back next week. We'll have another episode before we leave for CES. Jeremy will probably be back. Alan might be back.
We have no idea where Alan is.
But we'll be here. And that's really all that
I'm going to be here.
About. Josh will be here.
That's so nice.
I'm not going anywhere.
Josh goes nowhere ever again. Very true.
Pretty much.
So with that, everyone, just want to say thank you, and we'll be back next week. Thanks, guys. Good night. Bye.
See ya.
Merry Christmas and a Happy New Year. It's going to be 2018 when we come back again. 2018.
Oh, yeah, you're right. It will be.
I was born in 1972. Do you know how long when I was in high school and I did some calendar programs to see what happened in 2010 and made some little things? It seems so far away. And now we're in 2018. It's so far away. Life goes really fast, so you need to enjoy it. So anybody younger than 45, don't do what I did. Good night.
I found the comment that I wanted to point out before. It's from Toilet Bug, who says, he's talking about the book. Says, I need this on Audible so I can play it in the house stereo when I want my friends to leave. That would do it.
You screwed that up, Ryan. You need to leave enough of a gap so Alex could use that entire rant as the closing of the podcast, but you talked over him.
Did I?
Yeah,
it's fine.
You did.
It's fine.